Okay.
tomorrow when you come in.
I guess everybody wants to maybe hopefully join us at home. Well, hopefully. TJ's here. Wait, TJ and Peyton. And Jason. All right. So I'll let the kids in and see if they have homework questions they want to go over.
So you go 2, parentheses 1, plus 4, oops, is less than 5. And then from here, we go 2 times 1 is 2, plus 4 is less than 5. And then we want to say, is 6 less than 5? And TJ, is it?
No.
No. No, it's not. Good. Bill, what do we plug in for part B? Can you help me out there?
What did you say?
Can you, for part B, can you tell me what to write down?
2 for the x and then -1 for the y.
Yeah. Okay. So we get 2 times 2 is 4 minus 1. And then, Bill, is this going to be a solution?
Yeah.
Yeah. So that's how you check the solutions. And we did those kind of for homework, but now we're plugging in 2 variables instead of just the 1. Okay, so let's go to a checkpoint here. Check whether the given ordered pair is a solution. And we're just going to go through these again real quick. You want me to do this?
Yeah, you want to make 2 of them.
Yeah. We'll do the 0, 0 ones. The zeros kind of give us a little bit of trouble. Let's plug in. Remember, our x value is 0 minus 3 times 0 is greater than 4. And this we get 0 minus 0 is greater than 4, and 0 is greater than 4. Is that true, Jason? Jason, is that a solution? Peyton, is that a solution?
No, it is not.
No. No, it's not a solution. Let's look at this -1. We'll do part C as well. So we get -2 when you're plugging in for x minus 3 times -2. In this case, you get -2 plus a 6 is greater than 4. And then you get 4 is greater than 4. Is that a solution? Bill? Is 4 greater than 4?
No.
No. Yeah, so any questions on how to plug in for 2 variables instead of just 1? All right, let's look at graphing the inequalities. And notice, see the shaded region we were talking about? in blue. So it's a whole area that has solutions to the graph, and we'll talk about that. The graph of a linear inequality in two variables is a graph of all solutions of the inequality. The boundary line of the inequality divides the coordinate plane into two half planes. One half plane, which is shaded, contains the points that are solutions of the inequality. The other half plane, which is not shaded, contains points that are not the solution. So in other words, what this means is we are going to graph y. Let me change my color. We're going to graph in the form y equals mx plus b. That's going to give us this line right here. Once we get the line, we're going to determine should we shade on one side or the other. And that's going to give us many solutions. That line is now called a boundary line. And we'll talk about that more. But to determine that boundary line, we're going to do the same thing we've been doing from chapter 3. So the first step is to graph that boundary line. And then here's where you're going to come into trouble. If it's not an equal sign, you're going to use dashes. If it's less than or greater than. If it has an equal, you're going to go ahead and use a solid line. So the only change is when you use a dashed line, and that's when it does not have the equal sign below the inequality. After you graph, you want to test a point that is not on the boundary line to see whether it's a solution of the inequality. And then you want to shade either that side or the other side. So we'll go ahead and we'll do a little graph. Y equals -2. So I'm going to put a dot. For this case, your slope is 0 and your b is -2. So I'm going to put a dot on -2. And Peyton, using our definition for step 1, should we draw a dashed line or a solid line?
Dash.
Yeah. So we're going to draw a dashed line. And now we're going to do a test point. When you do a test point, please pick easy test points, one that are super easy to figure out. I'm going to go ahead and use 0, 0, because 0, 0 is typically an easy test point. You just plug in zeros. When we plug this in to y is less than -2, well, when we plug it in, you get 0 is less than -2. Chase, is that true? Is this point true? Is 0 less than -2? I don't know if his audio is working. Oh, okay. TJ, is 0 less than -2?
No.
Can you say that again?
No. No.
No, it's not. It's not less than -2. So that means that this is not a solution, which means that we're going to shade on the other side of the line. So we're going to shade this side of the line down here. If that were a solution, we would shade on the upper side of this line. Does that make sense? Okay, let's look at another one. And then again, this is just going to give us a horizontal line. X is greater than or equal to 3. So we're going to go to our x-axis. or sorry, a vertical line. And we're going to put a dot on 3. And Peyton, is this going to be a solid line we're going to draw or a dotted line?
Solid.
Yeah. And a way to remember it, if there's a line underneath the inequality, you draw a solid line. If there's not, you draw a dotted line. So you go ahead and draw your line. And then we pick a test point. Again, use the easiest test point you can think of. It's typically a good test point is 0, 0, not always. So it's use 0, 0. And then we'll figure out is 0 less than, or sorry, greater than or equal to 3. So here's my test point. Is that greater than 3? 0 greater than 3? Absolutely not. So are we going to shade on the right or the left, Bill? Which side should I shade on, the left or the right?
The right.
Yeah. So you're going to shade on the right-hand side of this line. And this is what your solution is going to look like. Huh? You mean part A? Yep. Perfect. Okay, so now we're going to look at 2 examples here. And we're going to graph just as if this was in y equals mx plus b form. Remember, if this was y equals mx plus b, our y-intercept would be 2. Or sorry, our slope would be 2 and our y-intercept would be 0. So we're going to graph it the same way. So I'm going to put a dot on 0. From there, I'm going to go up 2 and over 1, up 2 and over 1, up 2 over 1. Nothing's going to change with how we start the graph. You can also go down 2 and to the left 1. So I'll give you a second to put your points. Now, Bill, is this going to be a solid line we're going to draw or a dotted line?
Dotted.
Yeah, it's dotted because there's not an equal sign underneath the inequality. So then you're going to draw a dotted line. Through. Now here's something that we're going to get into. You notice that if we pick 0, 0, that is on our boundary line. So we cannot pick 0, 0. So we have to pick another point. You can use any point that is easy. Peyton, can you give me a test point that's easy to figure out?
1, 2.
Yeah. 1, 2, 1, 1, 2, 2. Yeah, absolutely. So we're going to use 1, 2. So in this case, oh, sorry, 1, 2 is on the line. How about we use, do you want to give me another one, Peyton?
2, 3.
Perfect. 2, 3, 2, 2. Yeah, use ones that are going to be easy for you to figure out. So we're going to do 2, 3. And when we plug in, we get 3 is less than 2 times 2. And we want to know, is 3 less than 4? In this case, yes, it is. So now we're going to go find that point of 2, 3. So we go in, we go over 2, up 3. And is this on the left side of the equation boundary line or the right side? Bill?
Right side.
Yeah, and it checks out. So we're going to go ahead and shade on that side. And again, if you want to pick one that's over here further, you can use like 5, 0. Anything would work. You just want to have one that's not on the boundary line, and whatever one is easiest. So this one's a little bit more complicated because we have to solve for y first. So I'm going to rewrite the equation, and then we'll solve for y. The first step would be to subtract over to 3x. And then we would divide by -2. What happens to the sign here?
It gets flipped.
Yeah, you flip it because we're dividing by a negative. So then we'll get a positive 3 over 2x minus 4. And we're going to graph that line just like we normally would. Our m is 3/2. Our y-intercept is, -4. So we put a dot on -4. And from there, we're going to go up 3 over 2. Up 3 over 2. And you can repeat the process until you have a good number of points where you feel comfortable you could draw your line. You could also go down 3 and to the left 2. TJ, is this going to be a solid line or a dotted line?
I can't see the symbol.
I had trouble hearing. Did you say solid?
I can't see the symbol.
Oh, right here. It has a line underneath, so it's going to be.
Sorry. Yeah. So it's gonna be a shaded in.
Okay,
It's a
first
solid line, right?
solid line. Good. Yep. You got it. So we're going to draw that solid line through, which mine's a little bit messed up. I'll try to redo that. And now we want to pick a point. In this case, it looks like 0, 0 is pretty far away from the line, so we could try that. So I'm going to do a quick test point. And again, these test points should not take you a long time. I'm going to use 0, 0. I'm going to plug back in the original equation here. So we get 3 times 0 minus 2 times 0 is greater than or equal to 8. And then we end up with 0 is greater than or equal to 8. Is 0 greater than 8? No. So that means this does not check out. And we're going to shade everything on the other side. So Bill, am I going to shade on the left side of the line or the right side of the line?
Right.
Yeah. So you shade everything down here. If you're using your pencil, if you're doing this on paper, just do a light shade. Try to do it real light. If you're doing it on one of these apps, try to use the highlight function up here. Makes it a little bit easier to shade. You can change the colors how you want it to be. Are there any questions on that? So it's definitely a new concept, but it just adds on to what we've been learning already. So Ms. Kane's going to go over tonight's homework with you.
All right, so if you travel to Google Classroom, the assignment for today is posted. It just uploaded. I'll let you travel over there and see if you can find it. It looks exactly like what is on my screen. The numbers that I would like you to do, we are going to do 1 through 9 odd. So we're going to circle 1, 3, and 5. That's testing to see if the ordered pair is a solution. And then we're going to circle 7 and 9. Testing to see if the ordered pair is a solution. After that, we're going to start at 11 and do 11 to 20, all of those. So the first 4 or 5 problems here are odd, and then we're looking at 11 to 20. So you're not going to do the last 2 problems at the bottom. So I'll go through, let's look at number 7. Number 7 says, is each ordered pair a solution of the inequality? So this is a yes or no question. These are 2 different ordered pairs. So we're going to test 3, 2 first, and then we're going to test -1, 4. Let's do that in another color. So my equation or my inequality is x is greater than 4. Well, the first x is 3, and we're just plugging in 3, and is 3 greater than 4? No. So that's all I have to do for that first problem, that first part with that ordered pair. The second part, again, I'm still using x is greater than 4. Well, here's my x in the second part. -1 is greater than 4. No, -1 is not greater than 4. It's less than 4. So you plug in each ordered pair, test to see if it's a solution. So you have to do number 9 as well. So number 9 says y minus x. Remember, y is the second variable. So y is -2 minus x, which is 5. I'm sorry, which is 3. And then is that greater than 5? -2 minus 3 is -5. -5 is smaller than 5. So now you just have to do that other one where you're plugging in the x and the y value. The first 3, you're doing the same thing, but you're just plugging in 0, 0 for 1, 3, and 5. So x is 0 and y is 0. So then you have to do 11 to 20, and you're doing all of them. Number 11 says identify 3 ordered pairs that are solutions to the inequalities. If it's a solution, Peyton, where should it be if the ordered pair is a solution? Where would it be located?
In the shaded area.
Yeah, in the shaded area. So there's so many different options that you could choose. As long as it's in the shaded area, pick a point in the shaded area and write that ordered pair. So identify 3 of them. So that's 0, 0. Pick 2 more for that shaded area. Same thing with number 12. Find 3 points. Pick 3 points in the shaded area. So you're not doing any work. You're picking 3 points in the shaded region to kind of identify that you understand where the solution is located. 13 and 14, if an inequality has the symbol less than or greater than, the graphed line will be, you need to fill in dashed or solid. So if it's less than or if it's greater than, Bill, is it a dashed or a solid line? If our symbol is less than or greater than. So Bill, if we have a less than or a greater than sign, will we make a dashed or a solid line?
Dash.
Yeah, thank you.
Sorry, I didn't hear you in the beginning.
That's okay, no problem. And then 14, if an inequality has a greater than or equal to, or a less than or equal to, the graph then will be solid. So that first page there is a lot of just kind of understanding the concept. The second page, 15 through 20, there are 6 graphs that you're going to plot on the given order or the given XY axis. And remember, we're looking at mx plus b. The first one, though, is different because it's just y. All the other ones have that mx plus b form. But 15 says y is less than 1. So we have to go to where the y-axis is located, plot a point at 1, because it just says y. Less than, Bill just said, less than means a dashed line. So making a dashed line. Oops. And then the last part, pick a point not on that line and test it. 0, 0, if it's an option, choose that point. So if I test the point 0, 0, my y is 0. Is 0 less than 1? If you say yes, then that's where you shade. If you say no, then you shade in the opposite location. Well, 0 is less than 1. So since it's yes, let me put a little check mark there. It's true. So it is yes. That means we are shading where the point is located. So we still have a few minutes left in class. Again, the problems on the worksheet that you are completing, 1 through 9 odd, 11 through 20 all. This is posted to Google Classroom, and you should have a good number of them done because we just completed some together. If you have questions, please ask. Have a fantastic 4-day weekend, and we'll see you on Tuesday. Come to school, join us in class on Tuesday. Have a fantastic weekend.
You too. Have a good weekend.
See ya.
Bye. Have a good weekend, Bill.